Arduino looped UART, and flashing LEDs. How are you, friends? I have long dreamed of developing the perfect wired communication network for the smart home. Its criteria are the minimum number of wires. Each node can be the initiator of data transfer, length up to 100 meters, simplicity, low cost, not high speed. I am not completely satisfied with any ready-made solution on the market. All communications are either expensive or difficult to master, or only allow 1 leader. I want to take as a basis the simplest, but also the most reliable of the physical ports of the controller. This is UART. I2C is also simple, but its speed cannot be reduced enough for transmission over long distances. As a rule, controllers have a choice of 2 high speeds. The UART port is designed to communicate only between 2 devices at a distance of about 50 centimeters using 2 signal wires, and through the usual input-output stage of the controller's discrete pin. Such an output stage can simply switch the controller supply voltage at the output, and the input stage can simply read the logic signal. Such signals 0 to 5 volts and 0 to 3.3 volts are subject to distortion when they are transmitted over long distances. But more about that in the following videos, in which we will find out how to get the most out of UART for practical purposes in home automation. I want to explore the hidden possibilities of the UART port, found in all the controllers of the Arduino family, for communication between several controllers at distances of tens of meters. For which I will begin my study with the ring structure of the network. The TX pin of each controller is connected to the RX of the next controller. Installation will be easy. The number of devices on the network is not limited. To test the operation of such a communication ring, I took 3 Arduino Nano. And with the help of LEDs I will indicate the successful transmission of a data packet. As a result of the experience, I want to get an alternate transmission of a data packet and an alternate blinking of the LEDs by the controllers that received data on the RX pin. The first attempt to create a sketch for the task in question looks like this. Here, an automatic random selection of the initiator of the first data transfer among the 3 controllers is implemented. After starting, the controller will wait for a random number of milliseconds in the range from 0 to 10. And, if no one has yet managed to transfer anything to the UART port, then this controller will be the first to send a unit in a data byte, which will fly to the next controller around the ring. And, if after loading the controller is late and has already received a byte of data, then it will turn on the LED for 1 second, turn it off, and after a second it will send a byte with a unit to the next controller in the ring in turn, and so on. Here is the result of running this sketch in practice. For some reason, 2 LEDs are lit at the same time. This sketch didn't work as expected, but it turned out to be a nice effect. It seems that here 2 controllers transmit data at the same time, that is, the first 2 initiators turned out. The connection works, but the sketch needs to be fixed. In the second version of the sketch, I simply uncomment the line with the transfer of the first byte to the UART when I select the first controller initiator, and load the sketch with this line commented out to the rest of the controllers. It turns out that I strictly manually set one of the controllers the function of the data exchange instigator. This time, only 1 LED is lit at a time, and we can visually follow the movement of a data byte from one Arduino to another. That's how it all turned out to be beautiful. In most cases, this principle of operation of the ring network will probably be preferable for us, since we will always know where everything starts. But there is one drawback: it is so inconvenient for unified devices on the network. Since there will be 2 sketches, one for the instigator and the other for everyone else. So it's interesting to develop a sketch with automatic assignment of the first transfer initiator. The third sketch will be the most advanced. Here, a variable of the byte type is introduced, which determines whether the controller was launched first of all. And, if it was the first, then it passes the byte with one to the next. And now, we see the result of the last sketch. It is identical in all network controllers. The LEDs successfully indicate data exchange on the looped UART port. On such communication, you can build the entire smart home system. Suppose some of the controllers will be responsible for reading sensors, some for actuators, and one or more will work as human-machine interface modules. All information should circulate in a circle in the network, both on incoming data and on commands to actuators. Each controller can read the information intended for it from the entire data array, which the controllers must transmit around the circle. And also each controller inserts its updated data into a common data structure. You get an interesting network. And its main advantage over a simple UART is the many connected controllers. But it has a number of significant disadvantages. The distance between controllers should be kept to a minimum. If the ring opens due to a wire break, or one of the controllers turns off or freezes, then the entire network will stop working. But such networks are widely used in systems with shift registers and address LEDs. However, there is no looping there and the entire network is controlled by one controller. As a study of UART in Arduino systems, it was an interesting experience. In the next videos, we will continue the research if there is sufficient support from you with likes and comments. Write in the comments, in which projects can you use a looped ring UART in your opinion? See you soon in new videos.